Hello, my name is Skylar McCaw, and welcome to my Lab 3 report about the magnetic field of a bar magnet. The goal of this lab is to see how the magnetic field changes as distance away from it changes experimentally, and will be done by measuring the distance dependence of the magnetic field of a bar magnet using a magnetometer app on my phone. I will then take this information and compare it to calculations done using the on and off axis equations from the Biot-Savart law. The existence of Earth's magnetic field makes this lab a little more complicated. If I want to measure just the magnetic field of the bar magnet, I need to make sure that the Earth's magnetic field is orthogonal to what I am measuring so my readings aren't off. I also need to make sure that I align the chip in my phone correctly, and I did this by creating an axis on my phone using tape and turning the phone different directions to get the right B sub x and B sub y values. Now that this is done, the experiment is set up and ready to go. Now to introduce a few important equations. The first is for the magnitude of the magnetic field, which is k times r to the n. K is a combination of unchanging constants and r is a separation distance, and I'm going to experimentally find n. I need to find a few average distances at a few different B sub x electric field magnitudes and use that data to make a plot using the next equation. Natural log of B sub x magnitude of the electric field equals natural log of k plus n times the natural log of r. This plot will be a straight line with slope n and intercept natural log of k due to its equation and properties. I then determined n based off the graph and mu based off the values given for the natural log of k. There is one last equation, equation 3, which I will need to be used in the coding portion of the lab. Now for the coding portion of the lab, which is all about the magnetic field off-axis. I performed a similar experiment to the on-axis version, but at a 45-degree angle with d equaling 0.163 based off dperp and physical measurements. I then went in and edited the code to create a model for this. I put in my measurements for dperp, as well as created arrows and edited the magnetic field function equations. Pictured above is some of the edited code, and the rest is linked below. Also pictured is the model of the code I created. What if I hadn't oriented my experiment to compensate for magnetic north, and had instead laid out my meter stick at some intermediate angle with respect to Earth's magnetic field? How would my results have changed? This would have caused all the readings I took when using the magnetometer to be off due to the effects of Earth's magnetic field, because it would most likely not be orthogonal. What if I were to stick two identical magnets together end to end and ran the experiment again? How would I expect my measurements to differ? The effect of adding a second magnet would cause the magnetic field to roughly double, as long as their lengths were minor, and therefore cause the distance measured to change as well. The final observation is that as distance increases, magnetic field strength decreases. That's all. Thanks for watching.